Welcome to MSR math classes. The topic is differential equation of class 12 CBSE syllabus. So last two exercises we have done based on the basics or introduction of the differential equation. First lecture was on order and degree of the differential equation, and the second exercise was on whether a curve is a solution for the differential equation or not. A curve is a solution for the given differential equation or not. But now here in this case, we are discussing like how to form a differential equation. When a curve is given, how do you form a differential equation? That is what we are learning. So to form a differential equation, we need to follow some steps. Those are the steps I have written over here. Just kindly check it. To form a differential equation from a given solution curve, use the following steps. The first step is observe the number of arbitrary constants in a given curve. So first we have to identify how many number of arbitrary constants are there. Suppose there are n arbitrary constants are there. Suppose n means a positive number only. Now after know that how many number of arbitrary constants are present, that many times we need to differentiate. That is the second step. So differentiate the given equation with respect to the dependent variable n times. When n arbitrary constants are there, n times we need to differentiate. And the third step is eliminate all arbitrary constants from the equation formed after differentiating in step 2 and the given equation. So use the given equation, and from step 2 we have to eliminate. By using these two steps, we have to eliminate arbitrary constants. And then next after removing the arbitrary constants, you will get an equation in terms of derivatives. That itself, the derivatives and constants and variables, that itself is a required differential equation. That is a step 4. So let's go with the exercise examples directly. Instead of learning separately the example, I'm going to choose the CBSE textbook questions. So in each exercise 1 to 5, form a differential equation representing the given family of curves by eliminating arbitrary constants a and b. So if you see here, it is a curve is given. Okay, for this particular curve, what is a differential equation we have to see. So what is the first step? The first step I told you that we need to find out how many arbitrary constants are there. A and B are two arbitrary constants, right? So the number of arbitrary constants are 2. What is the second step? We need to differentiate the given curve twice, because number of arbitrary constants are 2, so we have to differentiate the given curve twice. And then we have to eliminate arbitrary constant after that. Then the remaining whatever the obtained differential equation, you will get differential equation for this curve. So first I'm going to differentiate with respect to x. 1 by x differentiation is 1, 1 by a plus y differentiation with respect to x is y dash by b equal to 0. So from this one, y dash is equal to y dash by b equal to minus 1 by a, which is, when you send by b to the right hand side, it is minus b by a. Okay, so let us consider this one as equation 1, and y dash is equal to, in terms of this one, as equation 2. As I told you, since there are two arbitrary constants, we have to differentiate twice. Now again, do the differentiation with respect to x on both sides here, with respect to x. So y double dash, the right hand side we have the constant, so which is equal to 0. So can you see here directly, we are not using, of course, 1 and 2 equations directly. You can see there is a differential equation obtained which is independent of arbitrary constant. So this is the required differential equation, okay, for the given curve. So next, second question, y square equal to a into b square minus x square. Again, what is the first step? Identify the arbitrary constants. A and b are arbitrary constants. So second step is differentiate the given curve twice. So first differentiating with respect to x, y square differentiation is 2y dash into a into b square differentiation is 0 minus x square differentiation is 2x. So minus 2x. Both sides we have a common multiple 2. So which I'm cancelling both sides. So therefore we get from this one y dash is equal to minus ax. Let us consider this one as equation 1, this one as equation 2. As I told you already that we need to differentiate the given curve twice, right? So again I am going to do the differentiating with respect to x on both sides. So since y into y dash, y function in x, y dash is also a function in x. So we have to do the differentiation twice. Sorry, by using product rule. So y into y dash differentiation is y double dash plus y differentiation is y dash into y dash equal to minus a. So the product rule here I am using uv dash is equal to u dash v plus uv dash. Okay. Yes. uv dash. So here this is the third equation I can consider. Now can you see after doing earlier when we were doing second time differentiation it was free from arbitrary constant. Here after doing we have to work with an arbitrary constant. We have to eliminate this one by using equation 2 and equation 1. After first equation 2 is also containing a. Here is also it is a. So to avoid this a, I can divide the second equation by third so that a b get cancelled. So I am doing that only now 2 by 3. So which is y dash by y double dash plus y dash into y dash, which is y dash is equal to minus x by minus a. So minus a will get cancelled out. So y dash equal to x into y double dash plus y dash square. So this is the required differential equation, we can say. Or moreover, if you want to write, we can write y dash to the right hand side. That would be the final differential equation. X y dash plus x y dash square minus y dash equal to 0 is the required differential equation. Let's move to the third question. So here again, how many arbitrary constants are there? A is one of the arbitrary constant, B another arbitrary constant. And you see here 3 and minus 2 are fixed constants, right? So only two arbitrary constants A and B are there. So we need to differentiate the given curve twice. So first differentiation y dash is equal to e power 3x differentiation is 3 into e power 3x. E power minus 2x differentiation is b is there of course. E power minus 2x differentiation is minus 2 times e power minus 2x. This is the first time. Second time differentiation is 3 into e power 3x again 3 into. So 9a e power 3x plus 4b e power minus 2x. So let us assume that this is equation 1, this one is 2, this one is 3. Now we have to use 1, 2 and 3 and eliminate arbitrary constants a and b. Okay. So now here in this case, however, it is up to us, like whichever equations we want to use. The final aim is we have to find out a differential equation that is free from arbitrary constants. Now what am I doing here in this case? First equation I am going to multiply by 2, 1 into 2, which will give you 2y equal to 2a into e power 3x plus 2b into e power minus 2x. Now this is fourth equation. Okay. Now 2 minus 2 plus 4. I'm sorry. Why am I doing 2 plus 4? Because here minus 2x. Here plus 2b e power 2x. It will be avoided, right? Y dash plus 2y. The left hand side of equation 2 is y dash. Fourth equation left hand side is 2y. So adding them is equal to will give you 3a e power 3x plus 2a e power, which is 5a e power 3x. So from this one, I can calculate, I can write down a into e power 3x value as y dash plus 2y divided by 5. Now, can you see here a into 3 power x value is over here. Okay. Similarly, we can also obtain 2b, I mean b into e power minus 2x value, so that if I substitute over here, I can substitute the values of this one also. So to get that one, I need to do 2 minus 4 now. 2 minus 4, not 2 minus 4, I'm sorry. So again, to avoid a terms here from this one, I need to multiply the first equation by 3 and second equation by just 1 itself. So first thing is equation 1 into 3 we will do, which is equal to 3y equal to 3 power 3x plus 3b into e power minus 2x. This is fifth equation. Now fifth equation minus third, I'm sorry. Yeah, 3 into e power 3x, no? Yeah. Second equation minus third equation or fifth equation minus second equation is also fine. So 3y minus y dash equal to 3a into e power 3x plus 3b into e power minus 2x minus second equation means minus 3a e power 3x plus 2b e power minus 2x. So therefore, from this one, b into e power minus 2x value is dy minus y dash upon 5. So this is, let us consider it as some a and this one as b. Now we are going to substitute a and b in equation 3. Okay, that will give us the general solution, differential equation. Here y double dash is equal to 9 into a into e power 3x value is y dash plus 2y upon 5 plus 4 into 3y minus y dash upon 5. So this one you need to simplify here, which will give you the final solution. So 5 will be the LCM. Okay. So 5y double dash equal to 9y dash plus minus 4y dash, which is 5y dash. Next 18y plus 12y. 4 is raised to 1. 18 is 12y is 30y. So this will be the required general solution. So further, if you simplify also here, 5 ones are 5 ones are 5 6 are. So therefore y double dash minus y dash minus 6y equal to 0 is the required differential equation. Let's move on to the next fourth question. Y equal to e power 2x to a plus bx and two arbitrary constants, 2 times differentiation. Y dash equal to e power 2x, a constant differentiation is 0, b into x differentiation is 1. So let us consider this one as 1, this one as 2. Second time differentiation, b is as it is, e power 2x differentiation is 2 times e power 2x. So if you come 2 and 3, we can eliminate the arbitrary constant. But what about a? A should also be eliminated, right? That is also matter. So first thing is, yeah, just a minute here. We have a we forgot to do the differentiation, because here this is a function x, this is also a function in x. So product rule we have to use. I'm sorry. So first time this differentiation is over. Next e power 2x differentiation is 2 into e power 2x into a plus bx. Okay. So this is y dash is equal to b into e power 2x plus 2 into e power 2x. By the way, here this entirely can be replaced by 1. So 2y we can write it. Anyways, here the double derivative, next one for this one, 2b into e power 2x, this is right, and 2 into y dash. From 2, equation 2, we can clearly see that b into e power 2x value is y dash minus 2y. Right? This I am going to substitute in 3. So y double dash equal to 2 into b into e power 2x value is y dash minus 2y plus 2y dash. So therefore y double dash equal to 2y dash minus 4y plus 2y dash, which is equal to 4y dash minus 4y. That is exactly equal to y double dash minus 4y dash plus 4y equal to 0 is the required equation. Let's move the further question. Y equal to e power x into a cos x plus b sin x. Two arbitrary constants, 2 times the differentiation. First time differentiation, here we consider this one as u, this one as v. We use the product rule, e power x into the v dash first of all. So a into cos differentiation is minus sin x plus b sin x differentiation is cos x. This is over. Next, u dash e power x differentiation is e power x only, and the next one is as it is. So I have used here product rule. Further, we can simplify. What can we do? Or the second term is there now that can be replaced by, because it is as it is like the first equation. So this one will be replaced by y. So this is because from 1. So first time differentiation is over. Next again differentiation y double dash equal to same again, this one is u and this one is v. So e power x into the differentiation of this one is minus a sin x differentiation is cos x, and plus b into cos x differentiation is minus sin x. So minus b sin x plus, now this is u v na, u v dash plus u dash. U dash means e power x differentiation is e power x, and this one is as it is minus a sin x plus b cos x, and plus this term differentiation is y dash. By the way, I am considering this one as equation 2. So here again I have used product rule. So y double dash equal to minus of e power x into a cos x plus b sin x. Minus I have taken common, and now this e power x into minus a sin x plus b cos x. Can you see here? The same term is visible here. So this term entirely will be replaced by y dash minus y. So this is y dash minus y I am writing. And plus this one is y dash. This particular term obtained from equation 2. Okay. And this term is what? The first term, this entire term is nothing but y. So plus y dash, anyways, plus y dash is 2y dash minus 1. Therefore, y double dash minus 2y dash plus 2y equal to 0 is the required differential equation. We'll continue in the next video. Thank you.